Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss the purpose or the need of a page table and entries in a page table in detail. So I request everyone to watch the complete video for better understanding. In a paging, the main memory is logically divided into frames. Okay, we will have frame number 0, frame number 1, frame number 2, so on. And the process is logically divided into pages such as page number 0, page number 1, page number 2, so on. Okay, so a process is logically divided into set of pages and main memory is logically divided into frames. And remember one thing, always the page size will be equal to frame size. Okay, meaning is that one of the page from the process can be easily fit into one of the frame in the main memory. Now what will happen is that the process has to come into the main memory. So let's take that for a particular process you have three pages such as page number 0, page number 1 and page number 2. Okay, now the page number 0, let's take that it is there in the frame number 1. Page number 2 is there in the frame number 2. And let's take that in frame number 5, page number 1 is there. Is it clear? So page number 0 is there in the frame number 1. Page number 1 is there in the frame number 5. Page number 2 is there in the frame number 2. Let's consider that. Now, always CPU will generate the logical address. Meaning is that it will ask the xth byte in a process. Okay, it will ask the instruction which is there in 6th byte of a process or 4th byte of a process. So it will generate the logical address. The logical address will consist of two things. One is the page number and page offset. Okay, the page offset will depend on the size of a page and page number will depend on number of pages. Similarly, we will have a physical address, okay, which will consist of frame number to frame offset. Okay, so the purpose of frame offset is to know the frame size and frame number is used to represent the number of frames. So CPU will generate the logical address, but the physical address is in terms of frame number and frame offset. So you need one technique or some process to convert the logical address to physical address. So who will convert the logical address to physical address is memory management unit will convert the logical address to physical address. Okay, are you able to understand? Now if it wants to convert the logical address to physical address, it should know page number 0 in which frame it is there, page number 2 in which frame it is there. So somewhere the information should be there. So that information will be there in the page table. Okay, we will have a page table for each process, meaning is that each process will have its own page table. The page table will consist of several entries, okay, and the size of a page table will depend on number of pages. Okay, let's consider that this process has the three pages. So what information it will there is page number 0, page number 1, page number 2. It will have page number 0 is in there in which frame, frame number 1 it is there. Page number 1 is there in which frame, frame number 5. Page number 2 is there in which page or in which frame, frame number 2. Okay, so page number 0 is there in frame number 1, page number 1 is there in frame number 5, page number 2 is there in the frame number 2. Is it clear? Are you able to understand it or not? This information will be there in the page table. If this information, suppose if CPU is asking for the 6th byte, if that 6th byte is there in the page number 1, then it will go to the frame number 5 and it will fetch from the main memory. Is it clear? Are you able to understand it or not? Now the page table will also consist of frame number and other information also. So now let me discuss what is the other information it will consist of other than the frame number in a page table. Okay, and what is the purpose of each one I will discuss for you. And these are the extra information which is optional. Okay, are you able to understand? And this information or the format will vary from operating system to operating system. I am discussing the generalized version of the page table entries. Okay, already we have discussed about the frame number. Okay, the number of bits required to represent a frame number will depends on number of frames. The number of frames can be easily computed as size of main memory by frame size. Okay, if they have given the main memory size and the frame size, we can easily compute the number of frames. Suppose let's take that number of frames are 2 power m, then number of bits to represent each frame will be m bits. So we will have m bits for a frame number. Is it clear? Suppose let's take that number of frames is 2 power 20. Then 20 bits are required to represent one frame. So this frame number will occupy 20 bits in that case. Is it clear? Now we will discuss about the present or absent. Okay. Now let's consider that in a virtual memory, entire process may not be available in the main memory. Let's take that you have page number 0, page number 1, page number 2, so on, page number 3 in a process. Let's consider that page number 0 is currently in the frame number 5. Page number 1 is there in the frame number 6. Page number 2 and page number 3 is not uploaded in the or not loaded in the main memory. If they are not loaded in the main memory, what information we will have? We will not have the frame number. So we will have the present or absent bit or valid or invalid bit to represent whether the particular page is loaded in the main memory or not. If a particular page is not loaded in the main memory, then we will get the page fault. Okay, if CPU is searching for the page number 2, as instruction is not there in the main memory, we will say that it is a page fault. If CPU is searching for the page number 1, as it is there in the main memory of frame number 6, we will say that it is a page hit. So if CPU is searching for a particular page, if it is available in the main memory, then we will say that it is a page hit. If it is not available, then we will say that it is a page fault. So a particular page, whether it is available or not, we will get with the help of this information. Now protection. Now a particular page will have the information because a process will have the information. So the process is logically divided into certain pages. So page will have the information. So for that information, if you want to provide the protection, then you can provide. We will have 3 protection or 3 permissions. One is the read, another one is write, and another one is execute. If you want to give the permissions, then you can give. Suppose if user provided only read permission, then we cannot modify the information and we cannot execute it. So this is what the meaning of the protection bit. Each page will have read, write and execute. Okay. And the next one is reference. The reference will be useful in the page replacement algorithms. Let's consider that the main memory is full. Suppose let's take that main memory have 4 frames. Frame number 0, frame number 1, frame number 2, frame number 3. If main memory have 4 frames, at a time you can keep maximum 4 pages. Suppose let's take that page number 2, page number 3, page number 10, page number 15 are there. Okay, then CPU is asking for the page number 11. Whether the page number 11 is there in the main memory, it is not there. If it is not there, we will get the page fault. Now to execute the instruction, the operating system has to load this particular page into the main memory. If the main memory is full, if you want to upload page number 11, then what you have to do? You have to remove one of the existing page. Which page you have to remove will depend on page replacement algorithm. Okay, we have one of the page replacement algorithm is LRU, least recently used page replacement algorithm. So which page has least recently used, that one we will replace it. So to know that reference, we will have the reference bit. When it was least recently referred, when it was referred, how many times it was referred. Is it clear? So for that purpose, we will have this information. And then we have the caching enabled or disabled bit. What is the purpose of this one? I will discuss for you. Now we have the CPU, and we will have the cache memory, and we will have the main memory, and then we will have the secondary memory. Whenever CPU is checking for an instruction, first it will check in the cache memory. The cache memory is logically divided into lines, and already we have discussed that main memory is logically divided into frames, and secondary memory or the process is logically divided into pages. Remember one thing, the size of a line is equal to frame and page. Is it clear? Now CPU, if it wants to search for an instruction, first it will search in the cache memory. If the information is available, then we will say that it is a cache hit, and that instruction will be fetched from the cache memory. Instead of searching in the main memory and cache memory, secondary memory, it will first search it in the cache memory. If the information is not available in the cache memory, then it will start searching in the main memory. If the information is available, then we will say that it is a page hit. Okay, are you able to understand? Now if we keep the any page of the secondary memory into the main memory, then in the cache memory, suppose there was a data modification. If the data is modified in the cache memory, then here also it should be updated, here also it should be updated. But let's take that user is keep on typing the keywords. Okay, some user has opened the MS Word file and he is writing some letter. So whatever the information he is writing, it should be stored in the main memory. So that time, whatever the modification it is happening in the cache memory, it should reflect immediately in the main memory. So what a page table entry can have is that caching disabled or enabled. Meaning is that the particular page, if I say cache disabled, then the particular page will not be loaded in the cache memory. Is it clear? If it is enabled, a particular page can be there in the cache memory. So that is the purpose of cache enabled or disabled. Whether the particular page is allowed to store in the cache memory or not, it will say. Now dirty bit, meaning is that, suppose let's take that you have a page in one of the frame of main memory. Let's take that page number 0 is there in the frame number 1 of main memory. Let's take that this data is been modified, because we have read, write, execute permission. For the particular page you have given the write permission and data can be modified. Now whatever the data will be here will not be same. Suppose let's take that a is equal to 5 is data is there. Now user has modified a is equal to 5 to a is equal to 10 in the main memory, but in the secondary memory still it is a is equal to 5. Whenever the particular page is replacing, the data should be updated here also. So the dirty bit, if it is 1, meaning is that the data in the particular page has been modified. So whenever we are replacing the page, the value should be updated in the secondary memory also. The page should be updated in the secondary memory also. This is the purpose of present absent bit, protection bit, reference bit, caching bit, and the dirty bit in the page table entries. I hope it is clear for you. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.